This is the homework help video for Friday, October 28th. I recall from last year that this homework gave people a lot of trouble, so I'm hoping we had time in class to start it and talk about it a little bit. But if not, hopefully this will help. It's titled Number Patterns with a Rule. And let's read the top part. It says, each number pattern sequence below has a rule. These are the sequences, the sequence of numbers, and the rules are over here. It says to study the table, sequence A and its rule have been given. Use sequence A as an example to help you complete the table. So we have all these positions, n equals 1, 2, 3, 4, and 5. And for sequence A, the terms are 2, 4, 6, 8, 10. The terms are the number you get when you apply the rule to the sequence number, or to the position number. So when they've given us the rule, it's 2n. So when n equals 1, 2n is 2 times 1, or 2. 2n, when n is 2, is 2 times 2, which is 4. So you can see how we're getting how the rule works. Okay, if they've given you the rule, some of these problems they've given you the rule, so it's really easy in that case. You just apply the rule to you just use the rule and input the position number. 2n minus 1, so 2 times n, which is 1, minus 1. 2 times 1 is 2, minus 1 is 1. 2n, or 2 times 2, remember the n is coming from up here. 2 times 2 minus 1 would be 4 minus 1, which is 3. 2 times n, which is 3 in this case, is 6, minus 1 is 5. Now n is 4, so 2 times 4 would be 8, and 8 minus 1 is 7. Up here n is 5, so 2 times 5 is 10, minus 1 is 9. And you can also sort of see, if we're going 1, 3, 5, 7, 9, it's increasing by 2 each time. So you could use that to fill those in also. In fact, for sequence C, that's what we'll need to do because they haven't given us the rule in this case. So let's see how this is changing from here to here. 4 to 5, that's plus 1. 5 to 6, that's plus 1. So if it's increasing by the same amount each time, that's called an arithmetic sequence. And once you've identified the number it's increasing by, you can, or decreasing by, I guess if it was going down by the same amount, you can use that number and multiply it by n. So it's increasing by 1, so 1n, or just n, because 1n would be 1 times n, which is just n. So we start our rule with n, and then we see how we need to change it by adding or subtracting something. So when n equals 1, n would be 1, our rule would be 1, but our term is 4, so we need to add 3 to that, 1 plus 3. In this case, when n is 2, 2 plus 3. So it's n plus 3. The rule would be n plus 3. When n equals 3, 3 plus 3, that works. We get 6. When n is 4, 4 plus 3 would equal 7. And when n is 5, 5 plus 3 would equal 8. And we see our sequence still works. 4, 5, 6, 7, 8. It's changing in the way we would expect it to. These last two are a little bit tougher because you can see this is not an arithmetic sequence. That's increasing by 3. Then this is increasing by 5. So you have to look at the numbers. And when it's not an arithmetic sequence, it usually has something to do with n squared. In this case, that is the rule, n squared. When n is 1, it's like a square with side 1. We would have an area of 1. When n is 2, 2 times 2 is 4. When n is 3, 3 times 3 is 9, etc. So when n is 5, 5 squared, or 5 times 5 would equal 25. On h, they've given you the rule. It's the same as the last rule, but we subtract 1. So n squared minus 1. So when n is 4, 4 squared is 4 times 4 is 16, minus 1 is 15. When n is 5, 5 squared minus 1 would be 25, minus 1, or 24. So it's really easy once you're comfortable with using the rules and writing the rules, but I think that might take a little while to get used to. So hopefully with all these examples you can finish the rest, and we'll go over it on Monday. All right. Have a good rest of your weekend.